So, hello students, welcome back to the next lecture. So, this is about another fundamental thing in quantum mechanics called as the Schrodinger equation. SCHRO, two dots are given here as German. So, Schrodinger equation. Schrodinger equation. Okay. So, what is this actually Schrodinger equation? Okay, so in the year 1926, okay, Erwin Schrodinger, in the 1926, Erwin Schrodinger developed wave mechanics, okay, developed wave mechanics on the basis of de Broglie's hypothesis, okay, of wave particle duality. Okay, so now this Schrodinger equation is one of the fundamental fundamental means the most basic thing, means it is not derived from anything. Okay, fundamental equations of quantum mechanics. It is what? It is basically a differential equation. It is a differential equation of psi, that is wave function psi, second order differential equation with respect to space, and first order with respect to time. Okay, it is one of the most fundamental equations of quantum mechanics, and it's a differential equation in second order with respect to position and first order with respect to time. Okay, second order with respect to position and first order with respect to time. Okay, so now Schrodinger equation, I am writing it short form. Schrodinger equation plays the same role. Schrodinger equation plays the same role in quantum mechanics as played by the Newton's second law of motion, in classical mechanics. Now I think little bit you are understanding. Schrodinger equation plays the same role in quantum mechanics as played by Newton's second law of motion in classical mechanics. So how is that? What is Newton's second law of motion? Newton's second law of motion, what is that? F is equal to force is equal to mass into acceleration, m into d2x by dt2. Okay, so suppose a system that is like this, a simple harmonic motion. This is a body block of mass m, and it is attached with a spring like this, okay, of spring constant k. So m into d2x by dt2 will be what is equal to minus kx. So what we will do, we'll solve this equation, and after solving, I had done it in your, I think, first class only I have done it of this semester. Simple harmonic x comes out as x is equal to a something sine or cos kx minus omega t or kx, like that it comes. Okay, so this is the solution. So you are getting what? You are getting x after solving this differential equation. You are getting x. So from x you are getting x is just like psi only. So if you get x, you get all the information, you can get all the information regarding the particle. From x you can definitely find out the velocity by dx dt, you can find out the momentum by m dx dt, you can find out the kinetic energy half m dx dt square, that you can half mv square, you can find out the kinetic energy. Okay, you can find out the total energy by this. So similarly, here also in quantum mechanics also similarly there will be one equation called the Schrodinger equation. Okay, called the Schrodinger equation, and if you solve it, if you solve the Schrodinger equation, you will get psi. Okay, that's so psi will, as I told you earlier, that psi, if you get psi, you can find out all the things of the particle from psi. You can find out the probability, you can find out the momentum, you can find out the energy, everything you can find from there. Okay. That's it. uh, okay, so now uh, from the second postulate, from the second postulate uh, of quantum mechanics, each dynamical variable, from the second postulate, each dynamical variable is associated, each dynamical variable is associated with an operator. From second postulate, each dynamical variable is associated with an, okay, by an operator. Okay, now um, let us consider a particle of mass m. Okay, let us consider a particle of mass m moving with a say velocity, not velocity, let us consider a particle of mass m moving along the x-axis, with a fixed momentum, moving along the x-axis with a fixed momentum px and total energy E in a free region. This is very important. In a free region. Free region means the potential energy is zero. Potential energy is zero means what? That there is no potential gradient. That is, there is no external force applied. Okay, there is no external force applied on the particle. Okay, so total energy E in a free region, that is potential energy is zero. That is F is equal to minus dV by dx. There is no potential gradient. Okay, potential energy is zero. Achha, so uh, as okay, as no force is acting on the particle, as no force is acting on the particle, okay, it is who has no forces acting on the particle, it is moving in a constant potential. It is moving in a constant potential. Okay. I mean, you can also denote that it is constant potential, right? No force is acting on the particle. F is zero, so V is constant, right? F is zero, so there is no potential gradient, so V is constant. Free particle, free particle is no force is acting on the particle. Okay, you're free to move in any direction. Okay, so suppose you are in the heat college, but you are not coming to the class, you are not doing it, you are free, you are not, you don't bother about what sir says or madam says or anything, so you are free. Whenever you are bothering about what sir or madam says, then that means you are under the force of your sir or madam. Okay, so that kind of thing. So as no force is acting on the particle, it is moving under a constant potential. Okay, let us assume let us assume the potential to be zero. Let us assume that it is potential. Zero is also a constant. Let us assume the potential to be zero. Okay, let us assume the potential to be zero. Okay, so now uh, hence in this case hence in this case the total energy, hence in this case the total energy will be equal to the kinetic energy. Potential energy is zero. Okay, and let us consider the particle to be non-relativistic. This is a very important assumption of made by Schrodinger. Non-relativistic. There is a particle. Let us consider the particle to be non-relativistic. Okay. Let us consider the particle to be the non-relativistic particle. So, for this case, non-relativistic particle, the total energy E will be what? P square by 2m. Okay, P square by 2m. Kinetic energy will be P square by 2m. But if it is a relativistic particle, then that E would have been square root of P square C square plus m naught square C to the 4. Those things you have to. But no, this is a non-relativistic particle. That is, the V is much less than the speed of light. Okay, V is much less than the speed of light. So E is equal to P square by 2m. Okay. Achha. Now now if you do multiplying the wave function, multiplying the wave function psi, okay, multiplying the wave function psi on both sides, multiplying the left hand side and right hand side by the wave function right hand side by the wave function for a free particle, whether for a wave function for a free particle. Okay, psi xt. Okay. Okay, psi xt. Now what is the wave function for a free particle? Psi xt, as I told, is a into e to the power of I kx minus omega t, is a wave function for a free particle. Now so writing This is equation 1, writing equation 1 in operator form. Okay, every dynamical variable, that's why I had used this from the second postulate. Each dynamical variable is associated with an operator. Okay, so here E will be an operator, P also will be an operator. Okay, so uh, here E cap psi xt will be equal to px square by 2m into psi xt. Okay, now what is the operator for E? You know that I h cut del t, and plus psi is here, psi xt, I h cut del psi is equal to px square. Okay, so this will be 1 by 2m, px square will be what? Minus I h cut del x whole square into psi xt. Okay, so this will be I h cut del psi xt by del t will be equal to minus minus plus I square, minus h cut square by 2m into del 2 psi xt by del x2. Okay, this thing will come. So if you write it this thing, minus h cut square by 2m into del 2 psi xt by del x2 is equal to I h cut del psi by del psi xt by del t. Okay, so this equation is Schrodinger's this equation is Schrodinger's one-dimensional time dependent equation for a free particle having wave function psi xt equal to a e to the power of I kx minus omega t. Okay, so this is the thing. So now what will happen if we have done the easy we have started from the easy case, that is this free particle. So now now if the particle is not free, it will be acted upon by some external force. Which will be acted upon by some external force which will be characterized by a non-zero potential energy of the particle. Definitely, see here, if some external force is applied, definitely v will not be zero, not be constant also. Okay, so v will depend on x and t. So in that case, what will you write? E cap will be what? E cap will be px cap square by 2m plus v cap x comma t. Okay, so what will be the corresponding Schrodinger equation will be I cap will be what? I h cut del psi xt by del t. This will be equal to the same thing, minus h cut square by 2m del 2 psi xt by del x2 plus v of xt. We will now depend on x as well as time. V of xt into psi of xt. Okay, so you can write it like this. Just interchange the h cut square by 2m del 2 psi xt by del x2 plus vxt into psi xt is equal to I h cut del psi xt by del t. This will be called as the so this is equation this is equation number 2. Okay, so this will be called as the Schrodinger's one-dimensional equation for a for a one particle system. Okay, now in 3 dimensions, how will it will change? Just nothing, it will change in minus h cut square by 2m. That will be del 2 psi del x2 plus del 2 psi del y2 plus del 2 psi del z2. You will write that del square psi rt plus v of rt is equal to I h cut del psi rt by del t. This will be equation number 3. Okay, this will be Schrodinger equation in 3 dimension. Okay, and how you can write this? This is what basically this is kinetic energy, this is potential energy. So kinetic and summation of kinetic and potential energy was Hamiltonian. Okay, so you can write it h cap psi rt is equal to I h cap del t is what? E the energy is E cap psi rt. Okay, so this is the thing. Now another important thing is that this this is Schrodinger equation for non-relativistic particle. Schrodinger equation for non-relativistic particle. Schrodinger equation for non-relativistic particle. Okay, is for non-relativistic particle. I mean, Schrodinger equation is for non-relativistic particle. It is not for relativistic particle. Okay, and Schrodinger equation plays the same role. Schrodinger equation plays the same role in quantum mechanics as played by Newton's, oh this I think I had written, Newton's second law of motion in classical mechanics. Okay, and another thing is that Newton's law can be derived. Newton's law can be derived from Schrodinger equation. Okay, but Schrodinger equation cannot be derived. Schrodinger equation cannot be derived from anything. It is a fundamental property. Newton's equation can be derived from Schrodinger equation. Schrodinger equation cannot be derived from anything. Okay, it is the most fundamental equation It is the most fundamental equation. It is the most fundamental equation. So if somebody tells that derive Schrodinger's time dependent equation, so that is a very wrong sentence. Schrodinger equation cannot be derived. Okay, it is a basic postulate, you can tell. Okay, now this is your one-dimensional Schrodinger's one-dimensional uh, equation for one particle system, and this is Schrodinger's time dependent. This is Schrodinger's time dependent. Okay, Schrodinger's time dependent equation. Now, I mean, this question in your generally in exam, the question comes that write down the Schrodinger's time dependent equation in 3 dimensions. From that, derive the Schrodinger's time independent equation. From that, derive Schrodinger's time independent equation. So how will you do that? Okay, so Schrodinger's Schrodinger equation, अच्छा, time independent Schrodinger's equation. Okay, so now how will you do that? Achha. So let us start from the equation minus h cut square by 2m into del square psi rt plus uh, v of r, okay, into psi of rt is equal to I h cut del psi rt by del t. Now this is for the potential which are uh, only space dependent, not time dependent. Okay, so the potential energy of a moving particle, the potential energy of a moving particle is in general, the potential energy of a moving particle is in general a function of r and t. Okay, but in many cases, but actually in most of the cases in classical mechanics and quantum mechanics, it is seen that the potential is a function of r only, is a function of r only. Okay. So in those cases, for those cases we can use separation of variables. For those cases we can use separation of variables and get two independent equations, one containing function of r only and the other containing function of t only. Okay, so if the potential V is equal to the position of function of R only, the Schrodinger equation can be written as like this. This Schrodinger equation can be written like this. It's a function of R. So let this be equation. This is 2, it's 3, and this is equation number say 4. Okay, so by separation of variables, by the separation of variables, why we are doing separation of variables? Because you see here this is only the function of r, whereas psi is function of r and t. Here psi is function, here psi is function of r and t. So we need to do something such that the left hand side is a function of r only, right hand side is a function of t only. Then only we can solve this, otherwise we cannot do this. Okay, so the psi rt is equal to phi of r, this is a function of r only, and f of t, this is equation number 5. Okay, so if you do this, putting psi in 4, what will you get? Minus h cut square by 2m, okay, into del square of phi r into ft plus v of r into phi of r into ft is equal to I h cut into this psi will be this thing means del t of, instead of psi we are writing phi r and ft. Okay, phi r and ft. So what will you get? So here this is a function of del square is a function of what? Only r. So you will get here minus h cut square by 2m. Ft will come out. Ft for this del square is a constant. So ft will come out of the equation. Okay, ft will come out of the equation. So del square phi r plus this will remain like that only, Vr phi r into ft will be equal to I h cut. Here in this case phi r is a will be a constant since we are doing the derivation with respect to t only. So I h cut phi r into del t of ft. Okay, into del t of ft. Okay, so Acha. Now, what is the thing here? You see here that this is del square. Okay, and so you can write this, since this is only I mean this is the function of t only. So you can convert this to perfect differential ddt, not okay, partial differentiation. Since this is a function of only t, so you can convert this partial differentiation to perfect differentiation. Okay, achha, here achha, now see nicely that now you see the achha, okay, now let this be equation number 5. This be equation number 5. Okay, so here if you dividing both sides of 5 by phi r and ft, dividing both sides of 5 by phi r and ft, what do you get? What will you get here? ft will cancel, so this will be minus h cut square by 2m minus h cut square by 2m 1 by phi r into del square of phi r, okay, plus vr into phi r into ft, this will be equal to 1 by it will be I h cut 1 by ft into del sorry, no, it will not be del, it will be d, perfect differential, ddt of ft, ddt of ft. Okay. ddt of ft. Acha. Oh, this will not be there because you are dividing both sides by phi r and ft, so this will not be there. This will only it will be phi r. You would do both sides by phi r and ft. Dividing both sides by phi r ft. Okay, so this will not be there. So here, acha. So let this be equation number. Let this be equation number 6. Let this be equation number 6. So here the left hand side is a function of r only. Right hand side is a function of t only. Okay. Left hand side is a function of r only and right hand side is a function of t only, and which are equal. Now understand it very carefully. Left hand side is a function of r, right hand side is a function of t only, and plus which are equal. This is equal, left hand side is equal to right hand side. When can this be possible? This can only be possible when they are when both are equal to some constant. Now you will not understand that. How will you understand it? So suppose let us by the principle of homogeneity, I am just writing this to for making you understand. You don't need to write this in exam. This much you have to write, but you don't need to write this in exam. Suppose there is one function 3x square plus 5x. This is suppose equal to t square plus 2t. By principle of homogeneity, this cannot be equal. This cannot be equal. Okay. These two cannot be equal. 3x square plus 5x is equal to t square plus 2t. How can this be equal? This left hand side is a function of x. Right, again, see, right hand side is a function of t only. Okay, now suppose you take, say, you have got 10 samosas and 5 laddu. Okay, so can you subtract? If you do the subtraction, what will you get? Can you, okay, you will tell, okay, out of 10 samosas you subtract 5 samosas. That you can tell. But can you tell out of 10 samosas subtract 5 laddu? You cannot do. This is samosa and this is laddu. So you cannot do that. So this is meaningless. But for some particular instance, say for t is equal to 2 or x is equal to 1. Okay, say for t is equal to 2 and x is equal to 1. What will happen? For x is equal to 1, you see, left hand side will be equal to 3 plus 5, 8. And right hand side will be equal to, so 4 plus 4 to the 8. 2 to the 4, 2 to the 4, 4 plus 4, 8. Therefore, left hand side will be equal to right hand side. So only for this particular case, only this is happening to be equal. And what is that? This 8 is a constant. Okay, only for this particular case this is being equal. So 8 is a, so I think you have understood that for only this particular case, for t is equal to 2 and x is equal to 1, these are equal. Now what is that constant? T square plus 2 is 8. So this is a constant. Okay, so the left hand side here is a function of x only, right hand side is a function of time only. So this, how can this be? But you are seeing that this can only be equal for some particular case when this is equal to some constant. That is why you are telling that this can only be possible when both are equal to some constant. Okay, so now in some books they have written the E, total energy, but in this book also which I am discussing, they have shown E. But why it is E? They have not described that. So now let us therefore uh, this is possible when both are equal to some constant. Okay, so now let us take the constant as say some constant, that is minus h cut square by 2m 1 by phi r into del square phi r plus vr is equal to I h cut 1 by ft, this ddt of ft, this is equal to some constant, say the constant is g. G is a constant. G is a constant. Okay, G is a constant. Okay, so now let us let us solve this. So let us solve this one. So what will you get from here, this equation? dft by say ft will be equal to g into dt. Okay, from this equation 1 by h cut, so df by f is equal to g into dt, and I h cut is there. Okay, so g by say I h cut, g by I h cut. So what will be this? Okay, g by h cut. So here what will the I is in the bottom, so let us do multiply both numerator and denominator by I. So ig by I square, so minus ig by h cut into dt. Okay, so from here if you do the integration, what will you get? So integrating both sides, what will you get? If you integrate both sides, you will get log of ft will be equal to e to the power of minus ig by h cut, the e to the power of minus ig by h cut plus log of some constant. So that will be ultimately I mean like this, some constant. Okay, where c is the constant of integration. So c is the constant of integration. Okay, so one mistake I have done here. Integrating both sides, you will not do this. Integrating both sides will be actually ln of ft will be equal to ln of ft will be equal to minus ig by h cut into t plus ln of c, where is ln c, where c is the integration constant, where c is the integration constant. Okay, so now if you do this, it will be ft will be equal to c into e to the power of minus ig to the power minus igt by h cut. Okay, this will be the solution. So let this be equation number 7. Let this be equation number 7. Okay, this will be equation number 7. Okay, so now this will be what? This will be actually c into uh, cos of uh, gt by h cut plus uh, I into c into sine of gt by h cut. So now this is a harmonic term. This is a harmonic harmonic term, okay, which repeats itself after a certain period of time, after a certain period of time, okay. So harmonic term in the times there will be a frequency term. So what will be basically this will be c cos of omega t plus I c sine of omega t, where omega will be equal to g by h cut. Therefore g will be what? G will be equal to omega into h cut. So this will be omega by 2 pi into h, okay. And omega by 2 pi is what? Frequency, h into nu, right? So g will be equal to energy from the Planck's law. E is the what? E is the energy. So from here you will get that from here you will get so from equation 6, from equation number 6, what will you get? Minus h cut square by 2m into minus h cut square by 2m into 1 by 5. So now from equation 6 we can write that this thing, so minus h cut square 2m phi r plus delta plus vr is equal to I h cut 1 by ft, I h cut 1 by ft into dft by dt will be equal to the constant, and that constant we have found out to be the energy, okay. So if you take this one, what will you get? Del square phi r, okay, plus or rather minus 2m by h cut square into vr is equal to minus 2m is equal to minus 2m by h cut square into e. So from here what will you get? Del square phi r plus, if you take it here, 2m by h cut square into here there will be if you multiply both sides with phi r, there will phi r, here there will be phi r. So plus 2m by h cut square into e minus vr into phi r is equal to 0, okay. So this is what? This is the Schrodinger's time independent Schrodinger's time independent equation. This is the Schrodinger's time independent equation, okay. So questions can come in your exam that from the write down the Schrodinger's time dependent equation, from there derive, it will never tell that derive Schrodinger's time dependent equation. No, we are sure Schrodinger's, it cannot be derived, it's a fundamental equation. So from there derive the Schrodinger's time independent equation. So in this way you have to do. So minus h cut square by 2m 1 by phi r del square plus this vr will be equal to e. So from there, if we multiply both sides by 5, we will get multiplying both sides by, actually here, multiplying multiplying both sides by uh, minus 2m by h cut square into phi r. Okay, we get this thing, means del square phi r, here minus 2m by h cut square into phi r into here also minus 2m by h cut square into e into phi r is this. You take it here, so del square phi r plus 2m by h cut square e minus here into phi is equal to 0. Okay, so this is the Schrodinger's time independent equation. I think you have studied in chemistry also. So you can I mean, if yeah, we'll later on, after the next class, we'll do the applications of the Schrodinger's time independent equation. So there you can just simply write del square psi, no problem there. Okay, so thank you.